Hello guys, we have seen static implementation of many data structures, like we have seen static implementation of stack, queue, circular queue, priority queue. Now static implementation means implementation using array. There is another way of implementing the same data structure which is dynamic implementation. Dynamic implementation means implementing these data structures using linked list. Now linked list itself is a data structure, so from the next video onwards we are going to see the linked list, or we are going to start implementing the linked list. But in this video we need to discuss one important thing before we go for linked list, which is called as self-referential pointer. Now what is self-referential pointer, that we will see here. So employee.cpp is the name of the file. So here suppose I have some structure which is struct employee. Now in this structure I take some data members, say emp id is there, int emp id, then name of the employee is there, which is 20 characters long, and then double salary is there. So what is the size of this struct employee? The size of this struct employee is 4 for employee id, 20 for name, and 8 for salary. So 4 plus 20 plus 8, it is 32 bytes. Now suppose I create the variable of this struct employee, or I create the object of this struct employee in the main function. So it is employee e1, or you can say struct employee e1. Then this will allocate 32 bytes. Let me compile the code. Name of the file is employee.cpp. So if I compile this, it is getting compiled. Now the question is, can I create the variable of struct employee within that structure itself? That means suppose I try to create variable of struct employee here, struct employee e. Then what will happen if I now compile the code? Now let me check. This is not getting compiled. It is throwing an error. The error is field E has incomplete type. So error is because, why the error is here? Error is because, you know, when you declare any variable or when you declare any object, compiler should know the size of the object. So if I declare it here, compiler knows the size of the struct employee is 32 bytes. But here on this line, compiler don't know the size of struct employee since it is not fully defined. So this thing will throw error. Now instead of this e as a object, suppose I take this e as a pointer. Now whether it will get compiled or no, that I need to check. So suppose I compile it now. So it is getting compiled here. That means it is allowing me to keep the pointer of that structure within the structure. So this is possible because the pointer is always 4 bytes. So compiler knows the size of this pointer. Doesn't matter what is the size of data type, its pointer will be always 4 bytes. So here I am able to declare pointer of struct employee, and this pointer is called as self-referential pointer. Self-referential pointer means it is pointing to that kind of structure itself. So I am defining structure employee, and within that structure employee I am declaring the pointer of itself. So it can point to the variable of that structure itself, and that's why it is called as self-referential pointer. So we need to use this self-referential pointer in any dynamic implementation of data structure. It may be stack, queue, or any other dynamic implementation, like even trees, graphs. We need to make use of this self-referential pointer. So from the next video onwards we are going to implement a linked list. So please like the video and do subscribe to my channel if you have not yet subscribed.